Welcome everyone, and thanks for joining us today for our first webinar on experiment management. I'm Barrett Williams, Product Marketing Lead, and today I'd like to introduce SigOpt's Head of Product and Design, Faye Kalel. She's been working on adding modeling management capabilities to SigOpt for over a year now, and she'll explain how experiment management enhances the modeler workflow. Afterwards, our Head of Engineering, Jim Blomo, will present a demo complete with code samples, and we'll conclude with a question and answer session. Let's start out with an overview of our experiment management capabilities. Take it away, Faye.
Thank you, Barrett. Welcome, everybody. Thank you for making the time and joining us today. What I wanted to share with you is really a set of hypotheses that we tested in the marketplace in terms of what led us to build experiment management on top of our hyperparameter optimization platform. And it really was initially motivated by building on our mission to amplify the impact of modelers in their modeling every day and accelerate their work so their models get to production in a more productive and efficient way. As you have probably seen in all of the forecasts and market trends out there, 75% of enterprises today are building their AI models in-house. So they are really trying to own the entire life cycle end-to-end in terms of innovating with modeling. And that brings a lot of needs around productivity. 2 out of 3 models today fail to make it in production on time because of the iterative nature of modeling and the fact that it's really research driven, and there are a lot of strategies that get tried out before a model is adequately viable for production. And lastly, by end of next year, we'll have close to 60% of enterprises with a significant number of models in production, 20 plus, and that is pointing to a need for scale over the coming months. We ventured out and talked to about 100 modelers out there to try and understand some of their pain points when it comes to their modeling workflow. And some of the interesting observations we gathered were around how do we achieve explainability? How do we make sure we understand what transpired in our modeling workflow? Also, we heard things about how can I accelerate model releases and make sure that there is, checkpoints along the way, understanding how we're progressing, what else we're iterating on, what kind of strategies we as a team are exploring to make sure that model is viable for production. Another aspect that really speaks to our core specialty is optimization. How can you fine-tune your work, but also iteratively tune and train so you better understand what else you could do to improve the model over time. And then lastly, we also heard quite a bit of need around collaboration and the fact that the modeling teams in various enterprises have hybrid skill set, given the massive number of tools out there in the marketplace. And therefore, how do you allow people, when you hire them, to hit the ground running, to be productive, to not have to learn a whole new set of tools or stack, and be able to collaborate regardless of their experience? That also is becoming a very important need in building this entire life cycle workflow end to end. So the problems really, in summary, they center around modeling is siloed, is very research-like, and therefore you really need to track and organize progress. Modeling is about making trade-offs and exploring various strategies. So you want to understand and visualize the outputs of those strategies so you can analyze how to proceed. And lastly, the ability to get modeling right and ultimately get models to production faster really means that you needed to train and tune and iterate in the modeling workflow, but do so with quite a bit of collaboration with other colleagues so you can try different strategies. So along those lines, what we've set out to do is really build a model experimentation platform that helped us track everything you do in the modeling pipeline. And when you zoom out as to where that modeling pipeline fits in your workflow, it really is a core entity in the model, in the machine learning operations lifecycle. And we're really hoping today with what we're sharing with you, you'll see how you'll be able to featureize your work, your modeling work, be able to train various different model architectures, evaluate the results, maybe do some tuning, go back to possibly iterate on the features, and then ultimately progress to the ideal and optimal model. So without further ado, I'm going to jump into the demo. What I'd like to share with you today is a fraud detection problem that we are solving in a Jupyter notebook. So I'm going to here move from presentation mode. All right, and as you can see here, this is my Jupyter notebook. As I mentioned, I am using a synthetic data set, a Kaggle synthetic data set for this fraud detection problem that I'm trying to solve. And a first step here is to import libraries for this work. After your basic data cleaning steps, and I hope you can follow me there. What I started with is analyze the features that I have in my data set to really understand what features should I include, which ones should I maybe exclude. And the interesting part is in all of this analysis, all of this work is being tracked, since I am currently now with one line of code calling the SigOpt API to be able to track the work. But what's really interesting to share with you here is after I looked at that data, I defined my metrics. The important first thing in my actual modeling progress is I wanted to choose between two model architectures, an XGBoost model and a Keras deep learning model. And the first thing here I did is I tried an XGBoost model, and it shows me the output of that model when the run is finished in the SigOpt dashboard. So here I get to see the performance across my top metrics of this first XGBoost run. It gives me everything that has been tracked, from metrics to parameter values. This is not an optimized run yet, so it also indicates that to me and lets me know how I could perform an optimization when I'm ready. Metadata, everything around my code, my API object, in case later, for example, I want to reproduce a particular training run, I can go back in my dashboard and extract that code base easily. So that was like just, okay, so this is the XGBoost model, and these seem to be interesting outputs for those top two metrics. Going back, I'm going to try here a Keras deep learning model, as you can see there. Let's look at what's the output of that model. Here's the finished run. So in this case, it's a deep learning model, so I get a sense of the checkpoints, of how it converged over time. And then the same level of tracked information, performance across top metrics. The values here are significantly lower than what I've seen with the XGBoost. But everything else in terms of what's being tracked is, you know, the same set of parameters, metadata, code, my log there, as well as API object. So this already, looking at this view, I've already decided that XGBoost is performing better on my current data set. So I'm gonna go further explore that model architecture. And the next step I did here in my notebook is I tried to call in a simple SigOpt grid search to really understand how much further I can improve this model. So the experiment was created there, and this is the finished experiment. We'll pick one of these runs. So this is a run within that experiment, and same data gathered and tracked. These values seem to improve a little bit, but I'm also getting indication that I can go back and improve my features. So going back to my notebook, the next decision in my strategy is to design new features. And really to not dwell too much on this, because I want to show you some of the visual dashboards that you get to see with SigOpt. is that after I improved my features, I went back and ran a second XGBoost training run. And here are the results for that. And as you can see, the values improved. So obviously my feature analysis work there have helped to improve my outputs. So at this point, I'm definitely ready to run an XGBoost optimization, a SigOpt optimization, hyperparameter 1, and see what I get out of that. And here are all the observations. So let's select one of these. There you go, maybe this one. And then I'll show you the full spectrum of those observations or runs within this experiment. So here, as you can see, it's an optimization. I get a sense of the hyperparameters in addition to everything else that is tracked for a training run. But what makes it even more interesting is if I go to my top project page, I get a sense of how everything has really performed. All those training runs and experiments that I've been running, have they performed? These are the top results, and they can be, you know, also F1 score. I can look at here, my SigOpt optimization has yielded the best results. There are 20 runs nested within this experiment. And I can look at all of those. So let's look at that XGBoost optimization. It gives me a sense of how this model eventually progressed over time. So going back to my project page, this is a really good high-level snapshot, but I want to further analyze some of the work that transpired. So I can go into my analysis page. And here, let's get this feature analysis out of the way. So first of all, if I look at my parallel coordinates chart, and here I'd like to add my F1 score. There you go. I get to see how the F1 score and the AUPRC have really progressed over time there across all of my work. Also, I have this metrics versus parameters chart, which I can extend if I want to get a better look at these numbers. Another thing that I can do, and as you can see here, as I hover over one particular point, it shows me all the other metrics for that particular experiment or training run where they landed. This is very interactive. If I want to zoom in on some of these points, what I could do is here with the table, I get to filter results. So I can add a filter, for example, where the AUPRC is greater than 90%. And I'm gonna save that view as AUPRC higher than 0.9. All right, so what I get to do there is, if I look at only table filters, it reduces the number of points here. And as you can see here, my AUPRC, anything higher than 90%. So if I look at my F1 score, for example, this point seems interesting, I can select that, and it gives me a zoom in into the results there for that particular training run. Other things I can do from a visualization standpoint, for example, I'm going to remove this dashboard item. I'm going to add a new dashboard item. I want to look at checkpoints. In this case, I'm going to show all the data, so I get to see any particular deep learning models and their corresponding checkpoints. And as you can see, as I hover on these checkpoints, also the corresponding metric points are highlighted on the graph below. And obviously this is, in this particular case, it's just one experiment. So I fired off this project literally before the webinar here, but if I wanted to look at all my projects and go back to my homepage, if you will. This is where I get to see all of my projects and the projects I collaborate with my team on, some of my recent runs, my team's recent runs, some of the recent experiments. Some of the things that would be interesting to share with you is this other projects where, for example, we had a number of deep learning trials that we've done. So let's add that checkpoints chart here. And sure enough, you can see all the various experiments. And it's nice that there is interactivity within each dashboard item, but also cross dashboard items. So as I click here, the various points would highlight in the metrics versus parameter dashboard item there. Great. So I hope you get a sense of how SigOpt helps you track, how it helps you really visualize and make progress and inform decisions, but also collaborate as all these projects and these training runs are performed by various team members, and we get to see the collective view. We get to see the best results sorted by any particular one metric, and ultimately dive deeper into those results and understand how we arrived at the best model ultimately. So going back, in summary, really, what you get with SigOpt experimentation platform is this ability to transcribe your entire modeling workflow, where you can retrace and reproduce a lot of the decisions with perfect recall that you may have progressed through in your modeling. You get to actually look at custom visualizations that help inform your intuition about the outputs, but also help you understand for yourselves and explain with your colleagues on how that progress was established. And lastly, you saw how I did a simple tuning with SigOpt grid search, and went back to training. And then when I was comfortable with the model, I fired off a hyperparameter optimization with SigOpt. So there was a seamless iterative train to tune type of process that I engaged in there. And that really helped augment my work. A lot of these benefits are built on our leadership with the hyperparameter optimization platform, where we've seen 30% productivity boost across our deployed customer base, 8 times faster experimentation, as seen by some of the most demanding models for Two Sigma, a algorithmic trading firm. And a lot of these benefits really extend to the experimentation platform, so that now you can, as an enterprise, move in your ML ops infrastructure by having a modeling pipeline experimentation management platform that helps you really track and organize all the work, but establish a collaboration framework for your team. And with that, I'll hand it over to Jim for the technical deep dive.
Hi, everyone. So in the tech deep dive here, I want to show you the specifics of how to get started instrumenting your model. So on the next slide, we'll see some of the basics of how to install the SigOpt client. It's a simple pip install, and right now we support Python as the language for installing SigOpt client, and that will let you instrument, send, and receive information using our API for your modeling work. Because it's a simple client that can integrate anywhere, we support all of these different libraries that you see. So any type of training that you're doing, any type of model work or development, currently in Python, and though we're developing clients for other languages, we support it all basically. We've had a really wide variety of customers using this library and ability to support them all. Once you've installed the SigOpt client, we're going to be working through an example here in Jupyter Notebook, but this again will work in any environment that's running Python. So after you do the install, you can see here that we've started to instrument our model. And our model, in this case an XGBoost model, takes many different hyperparameters like learning rate, max depth, lambda, etc. And as we go through these different parameters, we'll be using the sigopt.com.get parameter to both log, sorry, can we go, yeah, thanks, Faye. So to both log those and in our optimization step, get even better parameters for us. We have other calls like log dataset, which help you keep track of which dataset that you're using, and log model, which help you remember which model you're doing. As Faye mentioned, the modeling process can be very iterative, and you may work on different datasets with different features. You may work with different models to see how they compare with each other. And being able to track all of this in one single platform versus platforms that specifically only support deep learning or certain types of training frameworks can be limiting in terms of getting a whole picture of your product. So our product is agnostic to all of that. You simply instrument it and it starts tracking all the different types of ways that you'd like to do modeling. For step 3, after doing that implementation, we're going to actually be doing the run itself. And so here you can see the xgboost.train method, which is training our model. And after that model is trained, we can get various metrics. In this case, we're getting back the F1 score, a balance between accuracy, or sorry, a balance between precision and recall, and logging that metric again. And Faye showed you the dashboard and the run information where that information shows up in our web application and lets you see these metrics across different runs, different models, and different data sets to help you better understand what's going on. We support dozens of metrics that you're able to record. We often find people need to look at a variety of metrics in order to really understand the model and how it's working and the trade-offs that are involved. This example just shows one, but again, you can log dozens. When wanting to move from a manual run like this one, and in this case, we're enabling this at the top of the cell with the %% run, but this is also supported on the command line or with client functions. So after you have done several runs and want to do an optimization loop, we can move to step 4. And in step 4, we're setting up an experiment. One of the ways that folks do experimentation is by testing different settings for their hyperparameters. And in this case, we're going to be tuning these different hyperparameters, the learning rate, max depth, min loss, min split loss, in order to increase our F1 score. So we define an experiment by specifying these different parameters, what their range is, their type, and later in this snippet, the metric that you want to optimize, either minimize or maximize. As Faye said, we've been working on this optimizer for a long time, and it uses some advanced algorithms in the back end to help get you the very best score in the least number of iterations. On the next slide, we can see that we did not need to change any of our code and simply needed to replace the %% run with a %% optimize. And what that does is it changes this cell from an individual run to a series of runs that intelligently tune the hyperparameters here so that we can get the best F1 score possible. And if you can go to the next slide, you can see what happens when an experiment completes, which is that you get a ton of information on our web app dashboard. This information helps you understand how different hyperparameters play into the metric you're trying to optimize. They contain advanced visualizations like this 3D visualization on the right-hand side that help you see the types of values that you're getting from your model. And as Faye showed earlier, they will show across different experiments, across different runs, so you can see all of the different types of work that you've been doing on your models. Faye, you can skip the demo here because you went through it already, and wrap up here.
Great. Thank you so much, Jim, for that deep dive. So obviously, next step, feel free to join us for a free beta. We would love to hear from you, see how we can help your modeling progress and get your feedback. We also have an academic program that you can join anytime. And I'd like to open it up for questions.
Thanks, Faye. So the first question we have from the audience is, by the end of July, what additional enhancements and features are you planning next for experiment management?
Great, thank you, Barrett. So some of the immediate innovations that are literally coming this month and the coming few weeks are, we're gonna introduce the ability of tagging, so you can, as you look at your model and your progress in the dashboard, you'll be able to tag your colleagues so that there is a little more collaboration. We're really focusing on enhancing the collaboration capabilities in the platform. We're also currently working with a number of beta users on their feature requests and wish lists, if you will, and we'll have more capabilities planned down the road. So stay tuned. We'll be posting blogs on our plans, but would love to hear from you on what else you'd like to see in the platform. And Jim, feel free to add any other thoughts you'd like to round up that answer with.
Sure, I think you covered it.
Excellent. Great. Any other questions?
Yeah, we have one more. So if you're an existing SigOpt customer and using it for optimization, what's the easiest way to modify your optimization workflow to add runs?
Sure, I think I can handle that. So as you saw here, we added this additional concept of runs. So there'd be 2 steps, working with our customer service team to turn on this beta capability for your organization. And then step 2 is tracking the runs from the start of your training and evaluation to reporting metrics and replacing the way that you currently report observations from an experiment. So that would be a straightforward change within 10 lines of code, and you'll be able to easily access these capabilities as well as the new capabilities of tracking runs independently from an experiment.
Got it. Cool. Thanks so much. I think that's all the questions we have for today. I'd like to thank our presenters again, Jim and Faye, for a job well done. And we encourage all of our attendees, if you haven't already, sign up for the beta at sigopt.com. Thanks, everyone. Have a great day.
Thank you. Bye.